first quadrant chopper, and get 240 volt DC source. So the input to the chip is 240 volt DC, and the output is going to a separate flexor DC motor. The constant the key operation, and the chopping frequency is constant at 50 Hz. So the chopping frequency is 50 Hz, whereas the field current is constant. The minimum load torque is 5 meter meter. This is the minimum load torque. Okay, now the minimum load torque at 500 RPM. That's the first question. So we solve always we solve the question. See, this is the question. We solve the problem. We solve the problem in such a way that we start with the question. What is the question? And as for the question, we will go ahead. What is the first question? The value of T on for minimum load torque of 500 RPM. We have the T on is how much? Is the question. So last class we have derived this thing T on. Okay. So how to derive the first? Let me draw that chopper here. This is the chopper. Okay. This is EA. So the voltage here is E naught, the output voltage. This is RA, LA, and EB is the back EMF here. Okay. So now EA how much has given 240 volts? You see the chopper voltage is 240 volts. Somewhere we have given this one. Yeah, yeah, this one. 240 volt DC source. Okay. And so E naught is there, EB is there, RA, LA values they have given. Okay, now what you have to find out? He is asking you to find out T on. Okay. He is asking you to find out T on. So how to find out T on? What is the formula you use to find out T on? Just recall what is the T on actually. Okay, if you recall, we can easily find out T on. Just I will write the expression for T on here. So what is T on from this? Okay, so last class itself we have derived the relationship between EA and E naught. What is the relationship between EA and E naught? Okay, so just recall what is E naught is equal alpha into EA. This is the relationship already we have derived. That implies E naught is equal. What is alpha? T on by total time period multiplied with EA. Yes, this is the formula. Now in this formula you have T on. T there. So using this formula we will find out T on. So to find out T on, what we require here, we need what is EA, we need what is T, we need what is E naught. So if we find out all these three, we can easily find out T on. EA already we know how much it is, 240 volts. You see yourself. EA is 240 volts. What is T? T is the time period. So time period in the sense, what is the problem he has given in the? He has given one data, that is chopping frequency. Chopping frequency is constant at 50 Hz. So the frequency is 50 Hz. What is the calculated before frequency? 1 by 50. This is the time. So we know to find out T on, we already know EA, we already know T. Only we need to find out what is E. If we can find out E naught, then we can easily find out so E naught we have to find out. So how to find out E naught? What is to find out E naught? E naught is the, what is E naught here? E naught is the output voltage of the chopper or input to the motor. Input to the armature of the motor. Input to the armature of motor. We find out input to the armature of the motor. So what is the procedure to find out? Okay, how we proceed? How we proceed with that? So there is a equation there. What is that equation? The equation here is input to the motor. What is the equation to the motor? To the input to the motor. So you apply KVL. If you apply KVL, you can easily find out. Here, if you apply KVL, you can be written as EV can easily out from this equation. E plus IAR. So, so if we can find out what is EV and IA, RA already he has given the data. How much he has given? 7.56 here. So you see the data what he has given? RA. You see, RA is 7.56. So we will take this. So here RA is 7.56. Okay. Oh, then what you need to know here? EV and IA, RA we have to know. So that is the only thing which is left now. So to understand this, okay, how we proceed with that? What is EV? EV is the back EMF. So how to find out back EMF? In the data he has given, what he has given in the data, we will keep the field current constant so that we it gives a rated operation on 230 volts. So motor voltage he has given. One motor voltage he has given. One motor current he has given. Let's see. So rated values he has given in the data. What is that? This is the this is the voltage. This is the voltage we have given. Okay, input to the motor, and this is the armature current. So rated values we have given. So we will do one thing. We will find out at rated values what is back EMF will come. At rated values what is back EMF. So how to find the we use the same formula. EA means that is the input to the motor. That is E naught I will take. E naught. E naught minus IA RA. Okay. So this equation always valid. Now we have to find out E naught at some other values. But first we will find out. First we will find out what is the back EMF at this rated values 230 volts. So from this EB is equal E naught. What is E naught? E naught is input to the motor 230 volts rated value minus current is 4.1 ampere that he has given into 7.56 RA value. Then how much you will get here is approximately you will get here. So we got approximately 199 volts. So we write here. So EB we got 199 volts. Okay. And then now we have an important observation. What is that observation? That so we got EB here. We can put EB here. Why we can put EB here? Because you see here. You see here. The question what has been of the value of Pn for a given torque of 500 RPM. So the speed at 500 RPM is asking. And at the same time, what is the rated speed here? 500 RPM. So the speed actually find out EB and the speed actually is asking question. Same both are same. When both are same, it means your vacuum is also same because the vacuum it depends upon speed. As is constant, speed constant in the sense the rated speed is also 500 RPM and the question also is asking to find out the value at the 500 RPM. So speed in both cases is same, so the vacuum in both cases is same. So it means the 199 volts which we find out here, we can use here. Here we can use. In the question, okay, E naught is equal to we can use. R we know. So we find out IA. to find out IA, we'll see now. One second. So how to find out IA? How to find out IA? So to find out IA, we'll recall some equations. Some equations which we have. Okay. What are equations which we have? If you just recall, it's a separately accelerated DC motor. So we have an equation T is equal to some constant K into IA. This we have an equation. This equation we will take the time. So in this equation, the serial in this, we need to find T naught. Why we need to find out T naught? To find out T on. To find out T on, only T naught is left now. So T naught we can use this equation. In this equation, we have find out EB. EB we have find out 199 volts. RA we know, and only unknown is IA. How to find out IA is that we have another equation in terms of IA, that is torque is equal to K into IA. So to find out IA, we need to know we need to know we need to know what is K and we need to know what is T. One by one we find out. What is K? K we can find out. It's a constant. So that constant, if you recall, EB equation has this constant. What is that? EB is equal to K into omega. We have this equation. Just recall that. Okay. For the separately accelerated motor, we have this equation. So from this equation, what we can do is that we can find out uh, easily what is K. What is K from this? EB. EB is how much? EB is 199 volts already we have right now, divided by omega. So omega in the sense, it is 2 pi n 60. 2 pi n is how much? 500 RPM. By the 60. Yes. So this way we can find K. What is K from this? What is K from this is that so K value we are getting 3.8. Okay. Or 3.8. So we write here 3.8. So we got A from this equation now. Only thing is what is left here now? I need what is torque. So to find out torque, okay. So we need to solve some more things. How to solve some more things is that do this now. How to solve it? Now we need to find out torque. Now in the problem, we have said minimum load torque. To find out the TNR load torque. Minimum load torque has given almost 5 meters. Okay. So minimum load torque that he has given is 5 meters. Not find out the electromagnetic torque. Electromagnetic torque. Electromagnetic torque. Rotation fast. Low. So electromagnetic torque we have to find out, then it is nothing but load torque plus torque due to losses. Yes, this is the formula we will use. Okay, to find out the electromagnetic torque. So in the problem he has given this as 5 Newton meter. So it's very simple. What is left now? What is left is now we have to find out the torque due to losses we have to find out. So how to find out the torque due to losses? How to find out the torque due to losses? First of all, what are the losses? What are the rotational losses? Because torque is related to rotational losses. Always remember. So we have to find out the power loss. We have to find out the power loss. Power loss. So rotation loss we have to find out. Okay, from the loss, that is from the power loss, we can easily find out the torque. Okay. So how to find out the rotation loss is that first of all, the motor. What is the because see rotation losses we will find out only once. Rotation losses we will find out only once. We will find out only once. Okay. So how to find out rotation losses is that first of all, first of all, because motor is there here. So we will write here. Then we have the motor. This is RA, LA. Okay. Here we have E naught. Okay. And this is the load, and this load of this particular system. So now here what we do is that in the problem, a rated input to the motor he has given. How much it is? 230 volts. A rated current he has given. How much it is? 4.1. Then what is the rated power? Rated power is 230 into 4.1. How much if we do this? To do this, 230 into 4.1 is 943 watt. So this you will get. So this is the rated power you will find. So apart from this rated power, now so it means this is the power which is going to the motor. This is the power which is going to the motor. So from this power, we have to subtract the losses in the armature winding, and what else we have to subtract? We have to subtract the output power. See here, input power is equals output power plus losses. This is formula we use. Okay, what is the output power? Output power depends upon the data. What is the data he has given in the output power? Please see here. What is the power rating of this motor? 1 horsepower. Yes, 1 horsepower. So 1 horsepower is the output power. So 1 horsepower in the sense how much? How much in terms of watts? It is 746. 746 watts. So this one is 943 and this one is 746. Okay. Now what are the losses now? Two losses we have found out. One is the losses in the armature resistance. That is I will take it as copper loss. So I square RA losses. So I square RA loss. What is I value? I value is 4.1 whole square into RA value is 7.56. How much you will get now? So use the calculator. Then you will get approximately 127 watt you will get. So one loss we got. What is the other loss? The rotational losses. The other loss is rotational losses. See why we are doing all this? Because we want to find out the torque because of the losses. Then only we can find out the electromagnetic current. That is the thing we are actually we are searching. So again we have to find out the rotational losses. So we will use this equation. Which equation input power is output power plus losses. Rated he has given rated current also he has given from rated voltage to rated current we can find out the rated power. Okay, so we got the rated power. How much we got the rated power? 943 watt. Then that is the input power. What is the output power? He said it is 1 horsepower. So 746 watt. Then plus losses. Two types of losses here we are considering because in the data also he has given. As per the data we consider only two. Copper loss in the armature resistance. So how we will find out that 4.1 whole square into 7.56 that is I square R. Then we got the copper loss. Then what is the other loss? It is like now rotation loss. So we will find out the rotation loss now. That is how to find out rotation loss now. 943 input minus output minus copper loss. So then whatever here that is nothing but the rotation loss. How much will get rotation loss if we do this? We will get 70 watts. So this is the rotation loss. So why we are finding out the rotation loss here? We need to understand why. Because we want to find out the torque because of the rotation loss. Then only we will add this to low torque. Then only we will get the electromagnetic torque. So now how do you find out the torque? If you know the power, we can easily find out the torque. What is the formula? What is the formula for the torque and the power? T is equal to P by omega. This is the formula. So P is 70. What is omega? 2 pi n by 60. 2 pi n by 60 in the sense 2 pi n in the sense 500 rpm by 60. We will use this, then we will get the value of torque. So calculator once again. So 2 pi n divided by 60. We have this into 7. Yeah, 1.366. 1.336. So we got the torque because of the 1.336 Newton meter. That's it. So we got this torque. So already we know the load torque. So then what is the total electromagnetic torque now? Total electromagnetic torque now is 5 plus 1.336. So we get 6.336 Newton meter. So this is the electromagnetic torque. Why we are finding out electromagnetic torque? Because is one equation. Electromagnetic torque is equal to T into Ia. We want to find out Ia. Find out Ia, we have already find out K, that is 3.8. Electromagnetic torque. We find out what is Ia. What is Ia from this we will get? Ia is equal. Ia is equal. Ia is equal. Ia is equal. We got 6.336 we got divided by K value. How much it is? 3.8. Okay. So just we are first we start with the question, and once we start with the question, we will go ahead what we require in the question. So as per that we will just solve the problem. Okay. So what is the answer? 6.336 by 3.8. So how much if we do that? Okay. If we do that, we will get an answer. I will write I then directly here it is 1.667. Yes, the armature current. So why we need armature current? Because we want to find out E naught. E naught has armature current. Everything we know except we don't know what. So what is E naught from this? E naught is equal to EB value 199 plus IA. Just now we find out it is 1.667 into RA 7.56. So we will do this. How much we will get here is approximately we will get here 2 lengths. So we find out E naught. So find out E naught. Why finding out E naught? Because EB, how we find out? We find out EB at the rated values only. Why? Because in the question also he is asking to find out EB, or he is asking the values at 500 rpm. The rated speed is also 500 rpm. So at 500 rpm we are finding out EB, that is 199. RA value we know. We don't know what is IA. How to find out IA? Because we have one equation, TE is equal to K into IA. K we find out from back EMF constant equation. E is equal to K omega. TE, what is TE? How to find out TE is that? TE is nothing but load torque plus torque because of the losses. Load torque he has given 5 Newton meter. Torque because of the losses we have to find out. To find out the torque because of the losses, first we will find out the power loss. How to find out the power loss? We have this equation: input power is equal to output power plus losses. Input power is the rated power, that is 230 into 4.1, that is 943, and output power is he has given the data as 1 horsepower, so 746. Now the losses are two losses are there, that is the copper loss and rotation loss. So the copper loss we find out from I square RA. So only rotation loss we can find out from this equation. That value we got 70 watts. So the power loss we find out. Then what is the torque because of the power loss? Is that T is equal to T by omega. So from that equation we find out the torque because of the loss is 1.336. Then we find out the total electromagnetic torque. Then we will go back to the previous equation, that is electromagnetic torque. Then Ia will find out 1.667 we got. Then we substitute Ia in the actual question E naught. Then we will find out E naught value. What we got the E naught value 211.6. Then we go back to the previous equation. So that is E naught is equal to T into so what is T from this? T is equal to E naught 211.6 into T. T is how much? 1 by 50 divided by EA value how much we got just now? 240. That's it. So you use this equation. You use this equation. From this equation, we can find out what is T on. How to find out T on? We'll see now. 211.6. 211.6. Okay. Divided by 50. Divided by 240. We got 17.6 milliseconds. So 7.6 milliseconds. So this is the value of T. This is the first question. So we find out the first question. So always we start with the question. We start with the question. Okay. So then we find out. What is the next question now? Next question is whether IA is continuous for the condition for part A. So we have to check whether it is continuous or not. IA. Recall the last class uh, waveform for the IA. What is the waveform for the IA continuous conduction we have seen? This is IA. So this value we take it as IA max. This value I will take it as IA minimum. Okay. So what we do here is that just recall what we do here. If you think it is continuous conduction, it is continuous conduction. He is asking whether it is continuous conduction or not. So we have to find out T from this. So we can find out the boundary condition. Boundary condition in the sense we have to find out the boundary condition. So boundary condition in the sense uh, what is the boundary condition? Boundary condition something like this. So this value, if it is 0, then we can easily find out what is the value it is like. So what we do here is that we'll give the hint here. What is the hint is that we have I naught value, IA max value, IA minimum value. These expressions we last class itself we got this expression. Okay. So what is the expression we got here? Last class itself we got this expression. What is the expression? Please, I will recall that we have derived last class. I naught max is equal, IA max is equal EA by RA 1 minus e power minus T on by tau divided by 1 minus e power minus T by tau EB by R. EB by RA. Everything we know here, except we may not know what is tau. Tau in the sense RA told you EA by RA. Usually what is IA minimum? EA by RA is on by tau whole by e power minus EB by RA. So here also same thing that we know T on, okay, everything we know. So what is the question he's asking actually? Question what he's asking is that okay whether IA is continuous for the part A or not. So T on, what is T on we got now? T on in the problem we got at 17.6 millisecond. Okay, so we'll do one thing that we will consider. For example, we will make minimum 0. You make IA 0. So if you make IA 0, then boundary condition this becomes 0. Then we find out what is T. So T is duration. So IA max, IA minimum. Okay. So we find T. So we'll make it 0. If we make IA 0, then we'll find out what is T. we find out and the actual T so if this T is more, then obviously it is continuous conduction. Otherwise, if this T is less, okay, the minimum T which we get here is less or more, it is lesser than the value, then it is continuous conduction. Otherwise, it is discontinuous conduction. You can easily solve this equation. So from the equation, we can get that thing. Okay, it's not a big deal here. Okay, and what is the last question? Last question is that the minimum value of T okay, for the coupling torque. So how do you find out that? The same procedure we will follow. We will follow the same procedure. Okay. So in this question, so part B, we are discussing about part B. In part B, we will use these two expressions. Okay, and we will find out T on. We find out T on. Already we got T on here, 17.6 milliseconds we got. Okay, T1 we got 72.6 milliseconds in the part A. So now we will check that. We will consider this as 0, then we will find out T1 and we compare both T1, whether the T1 which is here is lesser or higher. If it is lesser, it is continuous conduction. Okay, then whatever the T1 we got here, that is when we solve this equation, then we will use the T1 in the part C. What is part C question here? Part C question is that he's asking what is find out the minimum value of Tn for which the current is continuous at 500 rpm and the corresponding coupling torque is yeah yeah that we already find out. So we'll find out the coupling torque here. Coupling torque in the sense what we do is that we will out we got out here we got minimum from one we find uh, 25 volts into on T. We'll find out this one. Okay, so we find out the party. From party zero, then we'll get Tn. That Tn we'll put here. We'll put here, then we'll get the value of Ea. We'll get some value of Ea. Once we get some value of Ea, then what we do is that we'll find out Ia. How to find Ia or Ia? The equation is that Ia or Ia plus E is equal to Ea. Ea or E. Okay, so we have this equation. We got this equation. So from this we will find out Ia. How to find out Ia? E naught minus EB by. So see nothing else than here. We find out Tn from part B. That Tn we substitute here, then we get T naught. So E naught we got. What is EB? EB is already we find out at 190. Then divided by RA 7.56. Then we will get the value of Ia. So that Ia we will find out in the electromagnetic torque. What is that electromagnetic torque now? Some constant K. This value 3.8 we find out Ia. That Ia will put here. Then we will get the electromagnetic torque. Once we got the electromagnetic torque, we'll find out the losses from this electromagnetic torque, whichever we got, minus the torque because of the losses we will find out. That you will get the low torque. This equation we have already used. TE is equal to TA plus T loss. So TE we find out from this equation. T loss already we know that 1.337. That is the torque because of rotational loss. This we find out just now. So then what left from this you will get TL, load torque will get. So that load torque you have to find out. That's it. This is the third question. Here I will repeat the part B. Part A we find out. Then part B we will take the help of IA maximum, IA minimum. Then we using this we will find this here at boundary condition. Boundary condition. Okay. So we will take the help of this T on at the boundary condition to the part C. So in the part B we are just finding out. In the part B we are just finding out what is T on, what is minimum T on, so that it is still continuous. That is the logic. It is still continuous. That is the logic. So using this logic, okay. Using this logic, we will find out what is T on. So minimum T on. What is the logic here? Using this graph. Which graph? This graph here. So here you see the graph here. The boundary condition is there. When I minimum is equal to 0, okay, then that is a boundary condition. So using that boundary condition, we will find out T on. That is a part B. Now when we go to the part C, the Tn which we will use, which we got in the part B, we will use this equation. E naught is equal to 240 into Tn by T. Then we got E naught value. Then we substitute E naught in this equation. Once we substitute E naught in this equation, we will get the value of Ia. Then that Ia will substitute in the electromagnetic torque, that is K into Ia. Then from that electromagnetic torque, we subtract the torque because of the rotational loss, then we'll get the load torque. So that's the question he is asking in the part C is the what is the load torque? He is asking what is the load torque. You will use this equation. Okay. Then using this equation, we know all the things here. So with this problem will be over. Okay. So just it's mathematical solving of the part B and part C. We can complete the solution of this problem.